In this video, we have three rational functions. So that's just a fraction with a polynomial on the top and a polynomial on the bottom. And we're going to look at the behavior of these three rational functions as the absolute value of x approaches infinity. So as absolute value of x goes to infinity. So this absolute value means that we're talking about what happens as x goes to infinity and what happens as x goes to negative infinity. The way we want to do this is look at the power function approximations of the numerator and of the denominator, because as x goes to infinity, it's only the largest degree term that ends up mattering. You know, as x goes to 10,000, 100,000, a million, 10 million, this 4 gets more and more irrelevant. So what is the power function approximation? Well, we're just going to take the highest degree term of the polynomial when it's in standard form and the coefficient of that term. So the highest degree term of this numerator is 2. The coefficient of the x squared term is 1. So this is going to be approximated for very large x by x squared on the top. On the bottom, our highest degree is 3. And the coefficient of that term is also 1. So x cubed will be our power function approximation for the denominator. So now we want to look at what happens to this function as x goes to infinity. Since the degree of the denominator is larger than the degree of the numerator, the bottom of this fraction is going to grow much faster than the top of the fraction. So it'll start off the same. 1 squared is 1, 1 cubed is 1. But when we get up to a number like 10, 10 squared is 100, 10 cubed is 1,000. So you can already see the bottom of the fraction is starting to get much bigger than the top, and that'll continue to happen as the x values get larger. That's only at 10. So since the bottom is growing bigger and bigger faster, as x approaches infinity, this fraction is going to approach 0. So as x approaches infinity, this will approach 0. So we're going to have a horizontal asymptote at the line y equals 0. So if we plugged in 10,000 for x, we did 10,000 squared over 10,000 cubed, we're going to have a number that's very, very close to 0. For horizontal asymptotes, you're always going to have 0 or 1 horizontal asymptote for a rational function. So this is our only horizontal asymptote, y equals 0. Okay, down here for this next one, again, what we want to do is find the power function approximation and then look at what happens to that as x approaches infinity. So the power function approximation of this numerator, we're going to take the highest degree term, right here, x squared, and the coefficient of that term. So we have 3x squared. That'll be our numerator, 3x squared. For the denominator, our highest degree term is, again, x squared, and our coefficient is 5. 5x squared. So now, what is this going to approach as x approaches infinity? Well, whatever x is, when we square it on the top and we square it on the bottom, we can divide by that. So we can cancel the x squared on the top and the x squared on the bottom, because they're always going to be the same thing, so they won't change the fraction. So I'm going to get rid of those and those. And as x goes to infinity, this is going to go to 3/5, because that's what we have left after we cancel here. So there's going to be a horizontal asymptote for this rational function at the line y equals 3/5. Y equals 3 over 5. Alright, we got one more here. So again, we're going to do the power function approximation of the numerator and of the denominator. So for very large x, this function will be approximated by, on the top, our highest degree is 2, x squared, the coefficient is 1. So I'm going to put x squared here. On the bottom, we just have x, that's our highest degree term, degree is 1, coefficient is 1, so I'm just going to put x here. Now, if you prefer, you can cancel. So up here I have x squared over x cubed. I could have canceled, and we would have ended up with 1 over x. That's the same thing, I just canceled out x squared from the top and from the bottom. And we can do the same thing here if you prefer that. So I can make it x over 1. I just take an x out of both of them. Divide the top and the bottom of the fraction by x. And we're allowed to do that because I did the same thing to the top and bottom, so I did not change the fraction. So what's going to happen to this function, x over 1, as x approaches infinity? Well, when x is 10, this will be 10. When x is 100, the whole thing will be 100. So as x approaches infinity, this function is also going to approach infinity. Y will approach infinity. So there won't be any horizontal asymptote. If we graphed this, it would be the line y equals x. It's just going to go up forever. So there is no horizontal asymptote for this one. None.